Okay, so we talked about the benchmarks and stuff like that and converting from different forms. Let's look at how we actually do calculate with our percents. What we looked at with the fractions, converting a fraction into a percent, actually kind of leads us into how we do most of our calculations with a percent. If I have like 28%, we're going to list that as a fraction. It's 28 over 100. We're not going to bother to reduce it because we're going to be doing other calculations with it. And in most problems, there's going to be another number that matches up with the 28. It might be the number that we're looking for. So that there's a number that matches up with our percent. And that is, some textbooks have names for it, like the portion or the part. Some portion that we are looking for that matches up with the percent. And then there's a number, and this might be the number we're looking for, or it might be one of the numbers given, that matches up with the 100. That 100, not only is it there because it's 28%, so 28 out of 100, but that 100 also represents pieces in the problem. 100, or it can be thought of as 100%, is the whole thing. It's called a base amount. The whole or complete amount. The reason I call it a base amount is it can be one of two things. It can either be the whole thing, or it can be like a beginning value, what we started with. So if we take a look at some problems here, like find 27% of 300. Here we have the 27%. So I always want to start with the percent in these problems. It's easier for me at least that way. 27% is 27 out of 100. Now on the other side of this proportion, like we said here, there's another number that represents the 27. Do we know that number? Well, it's asking us to find 27%. So it's asking us to find that other number that represents the same thing as the 27%. So that's what we're looking for. So then we said there's a number that matches up with 100, which is the whole amount or the base amount. Think of it as the number we're trying to get out of. Find 27% of 300. Another way that could have been worded is 27% out of 300, which implies that 300 goes on bottom. Now, as we were looking at before when we converted our fractions back into percents, we can find this missing number by cross multiplying. 27 times 300 is 8100. And then dividing by the 100 is 81. So 27% of 300 is 81. This one, worded, phrased a little different, but still the same problem. Blank is 120% of 40. So we have the percent. We start with the percent. 120% becomes 120 over 100. Now again, we're looking at matching stuff up on the other side. We have those two other numbers. Here it's a little more obvious. We have a missing number, what we're trying to find, and we have the 40. One of them goes with the 120. Well, just looking at the wording here, blank is 120%. The missing number represents the 120. Of 40, again, we could think of that as out of 40. Implies the 40 goes on bottom. So once again, cross multiply and divide. 120 times 40 is 4,800 divided by our 100 gives us 48. Now, if we're using benchmarks here, does it make sense that this result is bigger than the 40? Yes. Can they tell me why? It's 120%. Being bigger than 100, our portion or the piece that we're looking at is going to be bigger than the whole amount, bigger than the starting amount. Looking at this one, again, worded, set up very differently than the previous one. We still have the percent, so I'm going to start 70%, do 70 over 100. Looking at the 30 and the missing number, which one goes with the 70? Well, this is 70% of 30. I think that's out of 30, right? The 30 goes on bottom. 70% is blank. The missing number goes on top. So it's worded very different, but it's set up exactly the same as the one up above here. So we'll go ahead and cross multiply and divide. 70 times 30 is 2,100. Dividing by 100 is 21. So 70% of 30 is 21. Well, all three of those examples we've seen so far are the same style problem. Let's look at one that's slightly different. Here we have 42 is blank percent of 30. Now we don't have a percent here, and I've always told you to, I've been telling you to start with a percent. But we can still do that. It's just blank over 100 now. And now we still have the two other numbers, in this case 42 and 30. One of them matches up with our missing percent, and one of them is that base amount that matches up with the 100. Now the wording here makes it pretty obvious which one's the base amount, doesn't it? Of 30 gives it away, is out of 30. We can also look at it, 42 is blank percent. That's showing us that 42 is linked to that missing percent. We cross multiply and divide. 100 times 42 is 4,200. Divided by 30 is 140. So 42 is 140% of 30. Now again, that makes sense because the 42 is larger than 30. It has to be more than 100%. So here we have blank percent of 80 is 32. Once again, I'm missing the percent. I'm still going to start setting up my problem with the percent by just doing blank over 100. Now I've got the 80 and 32. Which one goes on bottom? 80. It's often easier for me to find the one that goes on bottom because you're thinking of out of, and the wording usually gives that away. 32 goes on top. Some of you, by the way, in high school or middle school may have been taught is over of. For simple problems like this, that does work. But if we get into some of our word problems, that can get confusing with some of the wordier problems. So just if you use that, be cautious with it. Make sure you always go back and double check to make sure the numbers do link up. So now we can cross multiply and divide. 100 times 32 is 3,200. Divided by 80 is 40. So 40% of 80 is 32. So again, we had two problems there, worded very different, but they're the same setup. We might have $18 is 30% of blank. Well, now we have our percent again. 30% will become 30 over 100. On the other side here, we have the two numbers. We have the 18 and our missing number. If we read this, 18 is 30%. So the 18 goes with the 30. Our missing number is on bottom this time. So we'll cross multiply 100 times 18, 1800, and divide by 30 is 60. So 18 is 30% of 60. You could also run into 70% of blank is 56. Well, again, we have a percent. Let's start with that. 70% is 70 over 100. Now we have a missing number and we have a 56. Here it's probably easier for me to say of blank is implying out of blank. So our missing number goes on bottom. 56 goes on top. Cross multiply. 100 times 56. 5600. Dividing by 70 is 80. So 70% of 80 is 56. Now this is a proportion method. I like using the proportion for a couple of reasons. One is you just have to match things up, figure out what represents the same things. When we get into doing some word problems with this, it's exactly that. You find you match it up with the item that the item is represented by two numbers, the percent and then a whole number of some sort, and just match them up and they have to go together. The other reason I like this is once the numbers are in the proportion, the three numbers in blue here, the calculation is always the same. It's always cross multiply the two numbers that are on diagonal, then divide by the third number. We're not always cross multiplying the same direction. Here we cross multiply that way, but that's still the diagonal that has both numbers and still dividing by the third number. There are other methods of working with percents. The second most popular one that many of you might have been taught might have been something called the rate method of percents. And in the rate method of percents, we always convert our percent into a rate. A rate is nothing more than the decimal form of a percent. So 27% gets converted to 0.27. And we use that rate or that decimal instead of the percent. In a problem like this first example, it would be 300 times 0.27. It's going to give us 81. Well, that seems kind of simple. Let's look at our second one here. 120% is 1.2 as a decimal. That's going to be 40 times 1.2 gives us 48. Same answer. Again, it seems kind of simple. So why don't we use that rate method if it looks so easy? Well, because it doesn't stay that easy. Let's look back down here at some of our last couple of examples. This one here, 30% is 0.3. But to solve that problem, we're not going to do 18 times 0.3. It's actually 18 divided by the 0.3 to give us the 60. Same with this one down here. 70% is 0.7. That one would be answered by taking 56 divided by 0.7 to give us 80. So if we use the rate method, once we turn that percent into a decimal, we have to figure out then, are we going to multiply by that decimal or are we going to divide by that decimal? And then there's a third possibility, which is these middle two. If I'm looking for the percent, I don't have anything to change into a percent here. So what I have to do is I actually have to divide. 32 divided by 80 is 0.4. And then I move that decimal point to make it a percent. Same up here, I have to divide. 42 divided by 30 is 1.4. And I move that decimal to make it a percent of 140%. So that rate method, I will grant that it is much quicker, and if you're using a calculator, it's even quicker yet. But the difficulty with it is you have to remember, you have to look at the problem, and you have to figure out, once I change this percent to a decimal, do I divide by it or do I multiply by it? Or do I have to divide two numbers and move the decimal point later? Now, I'm not criticizing the rate method because that's actually the method I use if I'm doing stuff in my head or have to do it quickly with a calculator as well. But if I'm problem solving, I use that proportion method because it helps me set things up. There are a lot of examples out there. They're not part of this course, but if you did like a business math class or something like that, there are a lot of examples involving interest and commissions and stuff like that, where the rate method is much more handy to use, because we're always going to be doing this type of calculation where we are finding the percent of a certain number. And we have to do that same calculation with that same percent several times over. And it does make things simpler. Okay, so let's take a look now at some word problems with percents and see how this fits. Let's say that we predict %, I'm just throwing numbers out here, of patients will have an adverse reaction to a medication. How many patients were seen in a month where there were 152 adverse reactions. So we're using that percentage to complete our prediction here. So we have 8%. So I'm going to start out with 8 over 100, just like I did with the simpler problems. But now before I look at anything else, let's ask ourselves, what does the 8 and the 100 represent? The 8 represents what? The patients that have an adverse reaction. Very good. I'm just going to label that, adverse reaction. What's the 100 represent? Well, we said 100 always represents the number it's based off of, or the whole amount. The 100 here represents all patients. Now, for this to work, we have to know either how many people had adverse reactions or how many total patients there were. Do we know either of those numbers? Yes. The 152 is adverse reactions. So that goes on top with the 8, because both the 8% and the 152 both represent patients who had adverse reactions. Now, if we were given the number for down here, obviously there wouldn't be anything for us to do. Looking through the problem, there are no other numbers, so we know that's not given. But before we cross multiply and divide, we have to ask ourselves, is this what we're looking for? Are we looking for the total number of patients? Yes, we are. Now, that seems kind of silly to ask here, but in some other questions we come to later, that might not be what we're actually looking for. So now we'll go ahead and cross multiply and divide. 100 times 152 is 15,200 divided by 8. Gives us 1,900. So during that month, we saw approximately 1,900 patients. Let's say a doctor orders you to increase a patient's medication from 150 milligrams per hour to 210 milligrams per hour. What percent increase is this? I'm abbreviating here just to simplify things for you. So I've said that we always start with a percent. Here, are we given the percent? No, we are not. So we're going to do blank over 100. We have to ask ourselves, though, if we had that percent, what would it represent? Perfect, the increase. Very good. The 100 is our base amount. Now here we're changing from one value to another. The base amount would be the whole amount, or in this case, the starting amount. Starting or the initial amount. So on the other side of this, the starting amount is going to be an easy one to put in. What goes in there? The 150. That's what we started with. The top number there is going to be a little more difficult. What's going to go on top above the 150? Careful. We're not looking for the new amount. We're looking for, does the 210 represent the amount of increase? No. The percent we're looking for represents the amount of increase. There we go. 60 goes there. We have to do the 210 minus the 150 to get 60. So that's why I label these. It helps me figure out, wait a second, the 210 does not represent the increase. That can't be the number I put there. I have to find a number that represents the same thing as the percent I'm looking for. Now we can cross multiply. 100 times 60 is 6,000. Divided by 150 is 40. 40 over 100, or a 40% increase in medication. Any questions? So those are straight percent questions. Let's say that, let's look at this. Let's say that we, see, cancer patients, or the number of cancer patients has increased 3.5 times in the last 20 years. What percent increase is this? Now looking at that last problem, that was a percent increase. We had two numbers we could subtract. Here, though, we don't have two numbers we can subtract. Trying to set up a proportion here would get kind of confusing. What you have to see here, though, is we're not really doing with a proportion. All we're doing is a conversion here. Exactly. 3.5 as a fraction is just being converted into a percent. So you can think of it as 3.5 over 1 being converted into something over 100. So 3.5 or 3.5, if you want to do it that way. We could cross multiply and divide if we want to. Or like I said, we could change it to 3.5 and move the decimal point 2 spots. it's going to be 350. So it's 350%. That's a 350% increase over the last 20 years. So the doctor orders to reduce the medication. By 20% from a current order of 160 milligrams per hour. Find the new dosage. We can approach this in a couple different ways. We have the 20%, so that's 20 over 100. Of course, the 20 represents the reduction, right? 100 represents the starting amount, or the initial amount. Do we know either of those numbers? Yeah, we know that the 160 is the initial amount. That's what we started at. Is the amount of the reduction what we're looking for? Not really. It'll help us get to what we're looking for. But what we're really looking for is the new dosage. But we can go ahead and find that reduction. Cross multiplying 20 times 160 is 3,200. Divided by 100 is 32. That is the amount of the reduction. We are looking for the amount of the new dosage. So to find that new amount, we would do what? 160 minus 32 is 128. So the new dosage would be 128 milligrams per hour. Now I wrote it out like this purposely because what we're looking at here is the 160 is the initial or the starting amount. From that we subtracted a reduction or a decrease and we get a new amount here, the 128. And we can look at this, as I mentioned before, each of the items in a problem when we're dealing with percents is represented by a number and by a percent. So over here we have the numbers. The 160 minus 32 equals 128. On the other side we would put our percents. Well, the reduction is 20%. So 20 goes with the decrease, right? Now it looks like that's all we have for percents, but there's always something, there's always a number we have in our percents that's hidden, and that is the 100. What is the 100%? Starting amount. And we are subtracting here. 100 minus 20 gives us 80. So what we're really looking for is 80% of that starting amount. You don't need to know this term, but it's something called a complement. Whenever we have a percent, we also have a complement. Complements add to 100%. If we have a 20% reduction, that means we have 80% that's left. We've decreased by 20%, but there's still 80% there. And in this problem, it's not the 20% that we decreased that we're looking for. We're looking for the 80% that's left over. So we could have just found 80% of the 160. And if we cross multiply and divide there, we're going to end up with 128. Just, yeah, the 0.8 times 160, yes, that's fine. Now in this problem, like I said, it's about the same amount of work either way. But we do run into problems where we have to use that. For example, doctor orders to return to original dose. Current dosage is 340 milligrams per hour after a 25% decrease. So find that original dosage. Here, if I found 25% of, actually 25% is not what I was looking for. I meant to say 15% there, I'm sorry. Change that to 15% in your notes if you can. So anyway, here, your instinct is to find 15% of the 340 and add it back on. Problem is that 15% based off of the 340? No, it's based off of what the original dose was. We found 15% of the original dose and then we subtracted it back out. That got us to the 340. So we had our original, we subtracted that decrease to get us to what our current dose is. The words I put in here don't matter as long as you know what they represent. It's what they represent that's really important. On the numbers side of this, I have the 340. That is the current dose. That's after the decrease. On the percent side of things, I know that the decrease is 15%, but I also know, as always, the original was what percent? 100%. So the current is 100 minus 15, or 85%. Are we looking for the amount of the decrease or the original dose? The original dose. So we don't need the amount of the decrease. Now I could set this up in a proportion. I have 85 out of 100. The 340 goes with the 85 because they're on the same line, and then cross multiply and divide. Or I could just do it right here. 100 times 340 divided by 85. Gives us 400. The original dosage was 400 milligrams per hour. If you had tried to find 15%, by the way, that's only going to give you 51. You'd go up to 391. You'd be off by 9 grams. Similar to that one. After a 20% increase, current dosage is 516 milligrams per day. Find the original. So once again, we have an original dosage, but this time it hasn't been decreased, it's been increased. So we're adding an increase to it. And we're getting a current dosage. I have numbers and percents, just as always. I know the 20%. That's going to go for my increase. What other percent do I know? The original is 100%. Does that make the current 80%? Careful. What's it become? Perfect. It's plus. It's an increase. So we're going to add it. 100 plus 20 is 120%. The current dose is 120% of the original. 100 plus 20. And we know we have 516 milligrams in the current dose. Now, once again, we are finding the original, so we don't need the increase. So now I could set this up again as 120 over 100 if I wanted to, and the 516. I'm going to be lazy, and since I've got it set up here, I'm just going to cross multiply and divide right in the table. 100 times 516 and divided by the 120. 430, perfect. So the original dose was 430 milligrams, same units, so milligrams per day for this one. Any questions? Okay. So the last concept for today, the medical field is one of the few fields out there that still holds on to these. Slowly converting away from it. But we have to look at a little bit of Roman numerals. Our number system that we have is a multiplicative number system based on place values. Each digit is multiplied by a value that represents its location. In 382, the 2 is multiplied by 1, the 8 is multiplied by 10, and the 3 is multiplied by 100. It indicates their values. Well, in the Roman numeral system, it doesn't work that way. The location of the number, its value is only affected as how it's relative to the location of other numbers. It's what's called an additive system, where we just add the values together. It's like in the Roman numeral system, if we had a 9 and a 7, that would actually be just 16. It would be adding them together. So the Roman numeral system uses symbols to represent the values. Our standard number of 1 is represented with an I. Now, I am used to Roman numerals being capital letters, but in the medical field, they often use the small letters. Our number for 5 is represented as a V in the Roman numeral system, either small or capital. 10 is represented as an X. Go backwards here. 50 is represented by L. 100 is represented by C. You ever hear the term C note? It's a $100 bill. That's where that comes from. 500 is represented by the Roman numeral D. 1,000 is represented by M. Now there's one that's not on here yet. This is one I didn't learn until I started teaching this course. 1/2 is represented by SS. So if I want to represent the number 8, it's 5 plus 1 plus 1 plus 1. So V, I. That's the Roman numeral to represent our Arabic number 8. That works out fine, but to represent 9, they decided it was really clumsy to have VIII. So what they decided was they don't want you to allow to have more than 3 of the same symbol in a row. So here 8 with the 3 I's in a row, that's as far as they want to go. They don't want to have 4 I's in a row. So they use IX like this. What it is when you have a symbol for a smaller value in front of the symbol for a larger value, it is subtracted. So since the smaller value is first, that means the 1 is being subtracted from the 10 to make 9. Here, since the smaller values come after the larger values, they're added to make the 8. So if I want to represent 279, I start out with the larger digits first. I got to represent the 2. How am I going to do that? CC is 200s. So CC. How am I going to represent the 70? I'm going to have a 50 and, so an L and 2 X's, 2 10s. How do so you can see I'm just going digit by digit. How do I represent the 9? IX. Now let's go through this one. 3,000 is going to be M. 900. I can do 500 plus 4 100s, but that'd give me 4 C's in a row. So instead I'm going to do CM. Since the C is the smaller symbol, that means that the C is being subtracted from the 1,000 to give me the 900. So that's the 9. The 4 is going to be what? 40 will be XL. That's 10 taken away from 50. And the 9, IX. Perfect. Now I have students all the time, here where I went digit by digit, it's a little bit easier to explain. But what if I just wanted to represent 49? I have students all the time that just try to do this. Why can't I just do IL, right? That's 1 away from 50. Well, we don't do it that way. We go digit by digit. Even 45. They want to say, well, why don't we just do VL? That's 5 away from 50. The Roman numerals went digit by digit. So they represent the 4 first. So that's the X from the L. Then they represented the 9, which is the IX. Same with the 45. That's X from L, and then the V. So if you keep that in mind and avoid some of that confusion, you start at the beginning, you have to represent each digit individually as you go through. So what if I have that? How can I convert that back into standard numbers? I just want to take each symbol. M, I just have to verify, is the symbol after it bigger than it? No. Here it's the same. So I can do the next M. So I was going to put that M as 1,000. For this M, is the symbol after it bigger than it? Nope. So I put in the 1,000. C, is the symbol after it bigger than it? Yes. So I have to use those two together. That's 100 away from 1,000, or 900. L, is the symbol after it bigger than it? No. So I can just use the L of 50. X, is the symbol after it bigger than it? Nope. So I can use the X as 10. This X is also going to be 10. I, is the symbol after it bigger than it? Yes, it is. 10 is bigger than the 1, right? So X is bigger than I. So now it's I away from the 10. 1 away from 10 is 9. So just like you're going digit by digit, you just have to, before you add that value in, you have to check to make sure the symbol after it is not larger. So you know that you're adding it, not subtracting it. So here we have 9, 5, 6, 7, 9, and 2. 2979. More common, you guys have to read something like this. IVSS. What on earth does that mean? Exactly. The I, look at the next symbol, V is bigger than it, so we have to combine them. 1 away from 5 is 4. SS is 1/2. IX, of course, is simply 9. Good. What's that one going to become? So we've got the C here. Is the symbol after it larger? No. So put in the 100. Look at the X. Is the symbol after it larger? L is bigger than X, right? So we have to combine that. That's 10 away from 50 is 40. The 3 I's in a row, those are safe, right? So that's 1, 1, and 1. SS is 1/2. So yes, that's 143 and a half. What do you guys think? Hopefully you don't have to work with them very often. Huh? The one thing that's really confusing about the Roman numerals is a lot of times when they do Roman numerals, they write it backwards. Like we would do 12 grains, GR. They'll do GRXII. They'll put the label, the units in front of the Roman numeral. It can be a little confusing. Okay, so some homework that corresponds to this is to page 36 to 37, 1 through 51, the odds out of your book. And also page 39, 1 through 12. That deals with the Roman numerals. All we're doing is converting. We're not doing any operations, adding or subtracting with the Roman numerals. You guys really could not make me mad enough to force that upon you. Remember, next week, let's go ahead.
When you say odds, are you saying just do the odd numbers?
Yeah, like 1, 3, 5. That should be plenty. Remember, next week is test 1. That is going to be in the first hour. If you need a quiet location or whatever for that test, we'll mention it a little bit at the beginning of the hour next week, but generally plan on being back into the classroom like around 11:40 or so. It usually takes like a little bit more than the first hour. So about 11:40 we plan on starting our lecture. I will allow time if you have time for questions at the beginning of class next week. If you want to come in early, the other locations, the ITV people will be instructed to allow you to start taking the test anytime that morning. Here at Rice Lake, I am free at 9:30, so if you want to come in early, you can. Otherwise, I'm in this classroom with another class. If you want to come in before 9:30 and work in the next room, you can. Yeah, what's your question?
Are they on Blackboard or where are
Nope, the test will be paper and pencil. I will email it to the ITV coordinator at your location, and they'll have it printed off. They should have it printed off and sitting in the classroom for you, but if you come in early, you'll probably have to stop at the ITV office and pick it up from them.
Okay, so
Okay.